Good day and welcome to 501 Math Leap, where we work smart, not hard. In today's video, we're given this diagram and told that both circles have the same radius. And on the left, we have two tiny squares, each of area 10 square centimeters. And with just that information, we're to determine the area of that larger square on the right. So pause, give it a try, see what you can come up with. I'm gonna solve it this way. So first, let's begin by labeling some vertices from A all the way to H, J, K. Next, we know that the area of a square is given by side squared. And so, if we know that the area is 10 square centimeters, then we can find the side length, let's say BC, by finding the square root of this 10 square centimeters, which gives us that BC is root 10 centimeters. Now, because those are squares, if BC is root 10 centimeters, then CD is also root 10 centimeters, as well as AB. Now, we want to find the radius of the circle, so that would be the length AD. And since we have a right angle triangle, we can apply Pythagoras' theorem, which says that the square of AD will be equal to the square of AB plus the square of BD. So we know that AB is root 10 and BD is going to be 2 root 10. If we square those, we'll get 10 plus 4 times 10. So 4 times 10 is 40. 40 plus 10 gives us 50. So the square of AD is 50. Or in other words, we could say that the radius AD is root 50. Or in other words, 5 root 2. Now, how will that help us with the square on the right? Let's see. Well, first off, the length AD in the circle on the left will be exactly the same as the length GI on the right. Those will be the same radii. How do we know this? Well, we can deduce according to Taylor's theorem, named after Thales of Miletus, that anytime you have a diameter subtending an angle, it's always going to be a 90-degree angle subtended on the circumference. So here on the left, we have a right angle at vertex B, and on the right, we have also right angles at H or J, whichever you want to look at. So we can then conclude that AD squared, which is 50, is the same as GI squared. So moving on, we also know on the right side, the Pythagoras theorem will apply again. So the square of GI will be equal to the square of GH plus the square of HI. But since that is a square, GH and HI will be the same. So GH squared plus GH squared will give you 2GH squared. Now GI squared we know is 50. And if we divide that by 2, we get 25. But remember though that GH is the side length of the square, and if we square GH, that would be the area of the square. So we have found the answer. The area of the square on the right is 25 square centimeters. Did you get it right? If so, comment below. And as always, if you found this video useful or you liked it, please give it a like, share with others, and subscribe if you're new here.